The morning of March 6, 1944, brought crisp air to the 8th Air Force headquarters scattered across the English countryside. Inside the mission briefing room, the atmosphere was thick with cigarette smoke and tension. Weather officers moved between blackboards, their chalk scratching out wind patterns and cloud formations that stretched all the way to Berlin. The target loomed in everyone's mind: the Reich Air Ministry building. Opposition would be severe. Colonel Hubert Zemke stood before the tactical map, its surface covered with colored pins and pencil marks showing flight paths and danger zones. His fingers drummed against the wooden table as he studied the route. The secure telephone sat within arm's reach, waiting for his final authorization. 48 Republic P-47 Thunderbolts would climb into the gray English sky that morning. The 56th Fighter Group had been chosen for this mission. The 61st Squadron would take the lead position. The 62nd Squadron would cover the flanks. None of the pilots sitting in those wooden chairs knew they were about to demonstrate something extraordinary, the most devastating combination of survival and firepower ever seen in aerial warfare. Years of fighting over Europe had taught American commanders a harsh lesson. Fighter aircraft served two purposes in war. They were weapons of attack, yes, but more importantly, they were shields, protective barriers between enemy interceptors and vulnerable bomber formations. Break those shields, and entire squadrons of bombers would fall from the sky like wounded birds. The German Luftwaffe had learned this lesson too. Their Jagdgeschwader 2 and Jagdgeschwader 26 units had established defensive sectors that stretched from the Channel coast all the way to Berlin. Elite squadrons positioned at key points to intercept any American penetration into German airspace. These were not novice pilots. These were veterans. Messerschmitt Bf-109s and Focke-Wulf FW-190s filled German airfields across occupied Europe. The pilots who flew them had survived years of combat. They knew every trick, every tactic, every weakness in American formations. But the P-47 Thunderbolt was different from anything they had faced before. The massive fighter roared through English skies at 350 miles per hour. Its frame displaced more air than any single-engine fighter ever constructed. 8 tons of armor, ammunition, and engineering marvel. The sound alone was intimidating, a deep, throaty roar that announced American presence from miles away. Lieutenant Robert Johnson stood on the wing of his aircraft, examining battle damage from the previous mission. Bullet holes dotted the fuselage. Cannon strikes had left their marks on the wings. Yet here the aircraft sat, ready to fly again. The armor plating behind the pilot's seat showed impact marks, but remained intact. Self-sealing fuel tanks had closed around puncture wounds. The arsenal remained fully functional. 8 Browning M2 50-caliber machine guns were mounted in the wings. Each weapon could fire 800 rounds per minute when the trigger was pressed. High-velocity rockets hung beneath reinforced wing pylons. Bombs could be suspended beneath the fuselage for ground attack missions. The component that made aviation history possible sat in the nose. A Pratt & Whitney R2800 double wasp radial engine, 2,000 horsepower of raw mechanical power. The R2800 represented American engineering philosophy at its most robust and practical. Liquid-cooled engines failed when a single coolant line was severed. The pilot had perhaps minutes before engine seizure and forced landing. But radial engines were different. 18 cylinders arranged in 2 rows around a central crankcase. Each cylinder was independent. Individual cylinders could be destroyed completely while the remaining cylinders continued firing. The mathematics were brutal but simple. German 20mm cannon shells that would instantly destroy a Messerschmitt's cooling system merely damaged individual cylinders on the Thunderbolt. The engine kept running. The pilot kept flying. The mission continued. Combat statistics proved the point. The P-47 achieved survival rates that seemed to violate the laws of probability. Traditional fighter aircraft were lost in combat at rates exceeding 10% per mission. Young pilots climbed into cockpits knowing their chances of survival were poor. The Thunderbolt changed those calculations completely. Loss rate dropped to 0.7% per mission. Executive Officer Gerald Johnson had memorized those statistics. West Point educated with a mind for tactical analysis and mechanical systems, Johnson understood that aerial combat was ultimately about energy management. Physics governed everything. Altitude could be converted to speed at 32 feet per second squared. Target tracking required complex calculations. Deflection shooting demanded understanding of ballistics and relative motion. The difference between hitting a target and missing often came down to understanding physics better than your opponent. Exploiting mechanical advantages that superior engineering provided. German airfields across occupied France buzzed with activity that same morning. At a forward base near the coast, Oberleutnant Egon Mayer reviewed his ammunition loadout one final time. His Focke-Wulf FW 190A5 carried the marking Black 3 on its fuselage. Two MG 151-20 cannons were mounted in the wing roots. Each weapon held 250 rounds of mixed ammunition. Armor-piercing shells alternated with high-explosive rounds in carefully calculated ratios. Two MG-17 machine guns in the upper cowling contained 1,000 rounds each. 102 previous victories had taught Mayer exactly how American bombers should be attacked. Specific angles of approach were required. Ammunition management was critical. But the new escort fighters presented entirely different challenges. Intelligence reports described the P-47 as heavily armored and difficult to destroy. Multiple hits with concentrated fire were required to bring one down. German pilots were advised to target specific components: the engine oil cooler, the turbocharger intake, the cockpit area. Mayer had developed head-on attack techniques against B-17 formations over months of combat. 4 to 5 20mm cannon hits would destroy a bomber from the frontal aspect. 20 hits or more were required when attacking from other angles. The mathematics of destruction had been calculated through 3 years of bitter experience. But the P-47s seemed to absorb damage that defied all previous calculations. German pilots reported aircraft returning to base with over 200 bullet holes. Engines missing entire cylinders, yet still running. Control surfaces shredded, but still functional. Wings punctured by cannon shells, but still generating lift. The American formations assembled over East Anglia as dawn broke across the countryside. 3 squadrons flew search patterns as they climbed toward escort altitude. Equivalent formations spread to port and starboard. The 56th Fighter Group held the center position. Each Thunderbolt pilot swept the sky with his gun sight while checking weapon systems one final time. Training had refined their tactics through months of combat experience. Scan every few degrees of sky. Check blind spots constantly. Look for contrails against the blue. Weather conditions were perfect for long-range visual acquisition that morning. Clear skies stretched to the horizon. Temperature at altitude would reach -40 degrees Fahrenheit. Contrails were inevitable above 25,000 feet. Any aircraft operating at combat altitude would leave white vapor trails across the sky. At 9:15 on March 6th, Johnson's flight spotted the enemy formation approaching from the east. 16 Focke-Wulf 190s climbed steadily from low altitude, bearing 090 degrees relative to the American formation. Johnson pressed his radio transmit button and flipped his gun switches to the armed position. Bandits 3 o'clock high, 16 plus closing fast. In Mayer's cockpit, The fighter controller's voice crackled through the radio static. Achtung! Indianer approaching Sector Anton Bertha. Heavy escorts accompanying bomber stream. Mayer ordered an immediate combat climb. Full throttle settings engaged. Emergency boost systems activated. The BMW 801 radial engine screamed as methanol water injection increased power output to 2,100 horsepower. Climb rate increased to 3,300 feet per minute. Time to combat altitude calculated at 4 minutes 30 seconds. Executive Officer Gerald Johnson plotted intercept geometry on his knee pad while maintaining formation. Enemy speed estimated at 350 miles per hour. Combined closure rate approximately 600 miles per hour. The Germans currently held a 2,000-foot altitude advantage. The Thunderbolt's critical altitude was 30,000 feet. At that height, the turbocharger system provided maximum power advantage over naturally aspirated German engines. But engagement would occur at 27,000 feet, where both aircraft types performed effectively. Neither side would hold a decisive power advantage. The first engagement commenced at 9:23 that morning. 8 P-47s dove from 29,000 feet in a carefully calculated bounce attack. The maneuver was designed to convert altitude into speed and surprise. Physics worked in their favor during the dive. The Thunderbolts accelerated past 450 miles per hour as they plunged toward the climbing German formation. Armor-piercing tracers streaked through the morning sky in brilliant streams of light. The initial pass produced no hits on enemy aircraft. Clean misses all around. The German pilots had broken formation at the exact moment of attack. Their superior roll rate allowed rapid evasive action that spoiled the American gun solutions. Gerald Johnson adjusted his tactical calculations based on observed enemy reaction time. The German pilots were responding faster than expected. Approximately 2 seconds from visual acquisition of attacking aircraft to initiation of evasive maneuvers. He ordered a different approach angle for the second attack run. At 9:31, the second bounce attempt scored multiple hits on enemy aircraft. Concentrated fire from 4 Thunderbolts hammered a Focke-Wulf's engine cowling with 50 caliber bullets. Black smoke began trailing from the damaged fighter immediately, but the pilot retained complete control of his aircraft. Johnson could observe the German fighter's propeller still turning at normal rotation speed. The aircraft remained fully maneuverable despite obvious battle damage. The BMW 801 radial engine was proving nearly as robust as the American R-2800 power plant. The third attack came at 9:35. Johnson had calculated deflection angle at 30 degrees, based on target speed and crossing angle. But wind drift at altitude affected bullet trajectories more than anticipated. The stream of tracer fire passed directly behind the target aircraft without scoring hits. Mayer's wingman had executed a defensive barrel roll at the precise moment Johnson opened fire. The Focke-Wulf's superior roll rate of 160 degrees per second enabled standard evasion tactics that had kept Luftwaffe pilots alive throughout the defensive campaign over Germany. The fourth attack finally succeeded when Lieutenant Walter Beckham caught a Focke-Wulf in a climbing turn. 8 machine guns concentrated their fire on the enemy fighter for a full 3-second burst. 400 rounds of 50 caliber ammunition hammered the German aircraft from wing root to tail section. The Focke-Wulf's right wing root failed under the concentrated impact. Structural failure occurred instantly. The aircraft entered an unrecoverable spin toward the earth below. No parachute was observed during the fall. At 9:42, Mayer led his swarm in a head-on attack against Johnson's flight. Combined closing speed exceeded 600 miles per hour. Time in effective gun range would be less than 2 seconds. Split-second timing would determine the outcome. Both formations opened fire simultaneously at 800 yards range. tracer streams crisscrossed through the morning sky like deadly fireworks. Johnson's P-47 shuddered violently as 20mm cannon shells struck home against the airframe. 3 direct hits punched through the engine cowling. 2 more shells exploded against the right wing structure. A 6th shell detonated in the tail section behind the pilot. Metal fragments filled the cockpit air. Oil pressure began dropping immediately on the engine instruments. Cylinder head temperatures climbed toward the red line on multiple gauges, but the massive R-2800 double wasp continued running smoothly despite the battle damage. 2 cylinders had lost compression completely from direct cannon hits. Oil leaked steadily from punctured lines throughout the engine compartment, but 16 cylinders continued firing in perfect sequence. Redundant oil systems maintained adequate pressure for continued operation. The turbocharger assembly, protected by armor plating and mounted in the rear fuselage, remained completely undamaged. Johnson reduced power settings to 75% and turned toward home base. Engine temperatures stabilized within acceptable limits. 20 minutes later, Johnson's damaged Thunderbolt touched down at Halesworth Airfield. Ground crews immediately surrounded the aircraft to assess battle damage. They counted 43 bullet holes and 5 cannon strike locations. The aircraft would require 2 days of intensive repairs before returning to combat status. The pilot walked away from his aircraft completely uninjured. Not a scratch on him despite the heavy battle damage his fighter had absorbed. The mission had demonstrated the fundamental principle of P-47 design philosophy in the most practical way possible: survivability through mechanical redundancy, victory through engineering superiority. But broader tactical implications were only beginning to emerge from combat experience. The psychological impact on both American and German pilots would prove as important as the mechanical advantages. On June 26, 1943, the 56th Fighter Group had encountered Jagdgeschwader 26 over occupied France. 48 Thunderbolts against 16 Focke-Wulfs. The numerical advantage seemed to favor American forces heavily, but experience and tactical positioning gave German pilots critical advantages in the engagement. What followed would become the most famous demonstration of P-47 survivability in aviation history. A single aircraft's ability to absorb punishment that defied rational explanation. Lieutenant Robert Johnson flew tail-end Charlie position in the 61st Squadron formation that day. The most vulnerable spot in any fighter formation. This position was typically assigned to newer pilots as part of their combat education, learning to survive in the most dangerous location. His P-47C2RE carried serial number 416235. The name Half Pint was painted on the engine cowling in block letters. Standard armament consisted of 8 50-caliber machine guns with 350 rounds per weapon. Total ammunition load exceeded 2,800 rounds. The formation flew at 26,000 feet altitude, approaching the target area when German fighters struck from above and behind. The attack came without warning. No radio calls, no visual acquisition by American pilots. The first indication of enemy presence came from exploding ammunition and metal fragments filling Johnson's cockpit. 21 20mm cannon shells ripped through his fuselage in the first 2 seconds of combat. The instrument panel exploded in a shower of sparks and glass. The canopy shattered into hundreds of fragments. Hydraulic fluid sprayed throughout the cockpit under high pressure. A cannon shell fragment sliced across Johnson's nose, drawing blood immediately. Machine gun bullets punctured the oxygen system lines. Breathing became difficult at altitude. Fire erupted behind the engine cowling as fuel lines ruptured from multiple impacts. Johnson's P-47 rolled inverted and entered a violent spin. Centrifugal forces pressed him against the shattered canopy framework with tremendous pressure. The altimeter unwound rapidly through decreasing numbers. 20,000 feet, 15,000 feet, 10,000 feet. Standard spin recovery procedures required opposite rudder input, forward stick pressure, and neutral ailerons. Johnson applied all control inputs correctly. No response from the aircraft. The controls felt completely dead in his hands. Fire spread along the fuselage as damaged fuel lines fed the flames. Ammunition began cooking off in the wing magazines from heat exposure. At 4,000 feet altitude, the fire suddenly extinguished itself. Fuel starvation or oxygen depletion at lower altitude had starved the flames. The violent spin stopped abruptly. Johnson regained marginal control over his aircraft, but escape remained impossible. The canopy release mechanism had been destroyed completely by cannon fire damage. Melted plexiglass had fused around the canopy rails. Manual escape was impossible. The engine continued running roughly, missing on multiple cylinders, but maintained partial power output. Oil covered the forward windscreen completely. Forward visibility was zero. Peripheral vision was limited to small gaps in the shattered side panels. Navigation by magnetic compass was impossible. The instrument had been destroyed in the initial attack. Johnson turned west toward the English Channel, flying by instinct and sun position alone. Altitude held steady at 1,000 feet. Airspeed was unknown. The indicator had been shattered. Engine temperature readings were unavailable. All gauges had been destroyed. Fuel quantity was unknown, though gasoline leaked steadily from multiple puncture holes throughout the aircraft. The English Channel lay 50 miles distant across enemy territory. German anti-aircraft positions lined the coast ahead. Fighter bases at Abbeville and Poix contained aircraft that could intercept him easily. The probability of reaching England seemed mathematically impossible. Then Johnson spotted the worst possible sight in his mirrors. A Focke-Wulf FW-190 approaching from directly behind his crippled aircraft. Blue and yellow nose markings identified the aircraft as belonging to an experienced pilot. Johnson was completely defenseless. His gun sight had been destroyed in the initial attack. Hydraulic pressure read 0 on the remaining functional gauge. This meant no gun charging capability, even if his weapon system still functioned. Speed was approximately 200 miles per hour, barely above stalling speed for the heavily loaded fighter. The German fighter positioned itself for the perfect killing shot from close range. The FW-190 opened fire at 300 yards distance. Machine gun bullets hammered Johnson's P-47 with overwhelming violence. The sound was beyond description, metal shrieking as bullets punched through aluminum skin. The armor plate behind Johnson's seat rang like a giant bell as rounds struck it repeatedly. Fabric control surface coverings shredded into ribbons. Control cables frayed under repeated impacts. The instrument panel, already destroyed, disintegrated further under the concentrated fire. Johnson hunched forward in his seat, making himself as small as possible behind the protective armor plate. The German pilot fired precise, professional bursts, methodical shooting that conserved ammunition while maximizing damage potential. The FW-190's ammunition loadout included 1,000 rounds of 7.92 mm ammunition for the nose-mounted machine guns. The 20 mm wing cannons had apparently been expended during earlier combat. For 3 full minutes, the German fighter systematically pumped bullets into the crippled Thunderbolt. Short bursts aimed at critical components: engine cowling, wing roots, control surfaces, fuel tank areas. Every vulnerable point received concentrated attention. Johnson's P-47 absorbed this methodical punishment and continued flying straight and level. The R-2800 engine, despite running on only 14 cylinders, maintained adequate power for flight. Control surfaces, though thoroughly shredded, still responded to pilot input. Self-sealing fuel tanks, punctured multiple times, prevented catastrophic fuel loss through their rubber inner linings. The German pilot pulled his aircraft alongside Johnson's Thunderbolt. Through the shattered canopy remains, Johnson could see the enemy pilot examining his aircraft closely. The German pilot shook his head in apparent disbelief. No aircraft should remain airworthy after absorbing such concentrated damage. The FW-190 dropped back for another systematic attack run. More machine gun fire raked the Thunderbolt from nose to tail. Bullets walked across both wings, the fuselage, and the entire tail section. Elevator trim tabs were shot completely away. The rudder was holed repeatedly. Ailerons were punctured like sieves. Still, the P-47 continued flying as if nothing had happened. The German pilot pulled alongside again for another close examination. He appeared to be completely out of ammunition, or had simply given up trying to destroy what seemed like an indestructible American fighter. The German pilot looked directly at Johnson through the shattered canopy. He rocked his wings in what might have been a salute to a worthy opponent, then turned back toward France, leaving the crippled Thunderbolt alone over the channel. Johnson crossed the English Channel at 500 feet altitude. The engine was running progressively rougher. Power was fading gradually. Oil pressure hovered near zero on the single functioning gauge. The English coast appeared through the oil-smeared windscreen like a blessed vision. RAF Manston Airfield lay 10 miles inland. Johnson had no radio capability, no instruments, no way to signal his desperate condition to ground controllers. He approached the field at minimum altitude, hoping someone would recognize an aircraft in severe distress. The landing was more controlled crash than normal touchdown. No flaps available, hydraulics completely destroyed, no wheel brakes for the same reason. The main landing gear had locked down through emergency extension procedures, but that was all. The Thunderbolt rolled the entire length of the runway before grinding to a stop near the far end. Fire crews and medical personnel surrounded the stationary aircraft immediately. They could not open the damaged canopy. Cannon damage had jammed the mechanism permanently. Ground crews used fire axes to chop through the remaining plexiglass sections. Johnson climbed out of the cockpit, covered in hydraulic fluid, blood from minor facial wounds, and engine oil. He walked slowly around his aircraft and attempted to count the bullet holes covering every surface. He stopped counting at 200 holes on just one side of the fuselage. The other side showed similar damage density. Later detailed analysis revealed at least 21 20mm cannon strikes and over 200 machine gun bullet impacts. One cannon shell had passed completely through the armor plate behind Johnson's seat without detonating. The hole was perfectly round, exactly 20 millimeters in diameter. Half an inch movement in either direction would have killed Johnson instantly. The aircraft, designated Half Pint, was written off as destroyed beyond economical repair. But Johnson flew combat again just 4 days later in a replacement P-47. He would eventually score 27 aerial victories, becoming one of America's highest-scoring fighter aces in the European theater. His survival on June 26, 1943, became legendary throughout all P-47 squadrons, living proof that their aircraft could absorb battle damage beyond any rational calculation and still bring pilots home safely. The psychological impact on American pilot morale was immeasurable. The psychological impact on German pilots proved equally significant, but in the opposite direction. Intelligence reports intercepted by Allied monitoring stations revealed growing concern among Luftwaffe pilots about American superfighters that seemed impossible to destroy through conventional means. The term Betonflugzeug, or concrete aircraft, began appearing regularly in German pilot reports and intelligence assessments. Luftwaffe training manuals were hastily revised to emphasize attacking P-47s only with concentrated 20mm cannon fire aimed at highly specific vulnerable points on the aircraft. Captain Gabreski's landing showed the Thunderbolt's incredible toughness. His engine still ran on all 12 cylinders. The cowling looked like Swiss cheese from cannon fire. Holes peppered the metal surface in random patterns. Francis Gabreski would earn his place in history. 28 aerial victories made him America's top ace in Europe. Every single kill came while flying P-47s. His aircraft survived battle damage that would destroy lesser planes. The day that changed everything came on November 26, 1943. A 20mm cannon shell found its mark at 30,000 feet. The explosion ripped through his turbo supercharger system. Metal fragments scattered through the engine compartment. All boost pressure vanished instantly. The massive Pratt and Whitney engine began losing power. Gabreski felt the aircraft start to descend. 80 miles separated him from friendly territory. The R-2800 engine kept running despite catastrophic damage. Just enough power remained to prevent a forced landing. Enemy territory stretched below like a deadly carpet. Each mile covered brought him closer to safety. Ground attack missions revealed another face of P-47 survivability. Low-altitude operations meant concentrated defensive fire. German gunners could track targets easily at close range. Multiple weapon systems created overlapping fields of fire. Light flak guns fired continuously. 20mm cannons spat shells at rates exceeding 120 rounds per minute. 37mm guns added their deadly contribution. The air filled with explosive projectiles. Heavy flak presented different dangers. 88mm guns fired time-fused shells. Bursts appeared at predetermined altitudes. Black smoke clouds marked near misses. Direct hits meant instant destruction. The mathematics seemed impossible to survive. Thousands of shells filled small airspace volumes. Aircraft had to fly through this deadly maze. Yet P-47s consistently returned from missions that would be suicide for other fighters. December 23, 1944, brought the ultimate test. The Battle of the Bulge raged below. Weather grounded most aircraft across Europe. Visibility dropped below 1 mile. Clouds pressed down at 400 feet. The 56th Fighter Group launched anyway. P-47s attacked German armored columns at minimum altitude. Captain Robert Brookings pressed his attack despite withering ground fire. His aircraft absorbed punishment that defied belief. 87 hits peppered his Thunderbolt. Small arms fire punched holes through wings and fuselage. Automatic weapons raked the engine compartment. Cylinders disappeared in puffs of smoke and metal. Oil streamed from the damaged cowling. Control surfaces barely responded to input. The engine ran roughly on remaining cylinders. Brookings nursed his wounded fighter toward friendly lines. He made it home against impossible odds. The aircraft landed hard, but safely. Maintenance crews counted the damage in amazement. 3 days later, the same aircraft flew combat again. The 9th Air Force kept detailed records of ground attack operations. Their statistics told an incredible story. Between June 6, 1944 and May 8, 1945, P-47s flew 135,000 sorties. Enemy fire damaged 4,293 aircraft. Combat destroyed 824 completely. The survival rate after battle damage reached 80%. No other fighter matched this incredible record. Lieutenant Colonel Kynard's experience proved typical rather than exceptional. January 1, 1945, brought another demonstration of P-47 toughness. He attacked a German supply train carrying ammunition and fuel. High-tension wires crossed the railroad tracks. Kinnard's propeller blades struck the cables at high speed. Metal twisted and bent from the impact. The engine cowling crumpled like paper. Oil cooler lines severed completely. Coolant began streaming from damaged radiators. The massive R2800 engine started overheating immediately. Temperature gauges climbed toward red lines. 40 miles separated Kinnard from his home base. The engine ran hotter with each passing minute. Oil pressure began dropping dangerously. Steam rose from the cowling in white plumes. He landed just as the engine seized completely. Pistons welded themselves to cylinder walls. The propeller stopped turning on final approach. Mechanics worked through the night replacing the entire power plant. 1 week later, the aircraft returned to combat. Fresh engine, new propeller, patched cowling. Ready to absorb more punishment in the endless air war. The cumulative effect devastated German transportation systems. P-47s claimed 86,000 railway cars destroyed. 9,000 locomotives lay wrecked in rail yards. 6,000 armored vehicles burned beside roads. 68,000 trucks littered European highways. The transportation network supporting German forces collapsed completely. Not from high-altitude precision bombing, but from P-47s absorbing ground fire that would destroy conventional attack aircraft. They pressed attacks home regardless of damage. Pilots knew their aircraft would probably survive. That confidence translated into aggressive tactics. German defenders faced opponents who seemed impossible to stop. The Pacific theater presented different challenges entirely. Vast distances made engine reliability absolutely critical. Single engine failure meant ditching in shark-infested waters. No rescue ships patrolled empty ocean areas. Yet P-47s achieved the lowest loss rates of any Pacific fighter. The R2800 engine's reliability saved countless pilots from water landings. Even severely damaged engines kept running long enough to reach friendly bases. Colonel Neil Kirby commanded the 348th Fighter Group in the Philippines. October 11, 1943, brought the ultimate test of P-47 combat effectiveness. Leading 4 Thunderbolts, he encountered 36 Japanese aircraft. The odds seemed hopeless, 9-1 against. Japanese pilots expected easy victories over outnumbered Americans. They attacked confidently in overwhelming numbers. The combat that followed shattered their expectations. Kirby personally destroyed 6 enemy aircraft in the swirling dogfight. His Thunderbolt absorbed multiple hits from Japanese machine guns. 7.7mm bullets punched holes through wings. 12.7mm rounds hammered the fuselage. The P-47 kept flying and fighting effectively. Kirby would score 22 victories before overwhelming numbers finally brought him down. March 5, 1944, marked his final combat mission. Japanese pilots developed genuine fear of P-47 encounters. Training manuals designated the Thunderbolt as the monster. Its size and apparent indestructibility defied their combat experience. Standard hit-and-run tactics proved completely ineffective. Brief firing passes failed to inflict sufficient damage. Extended combat exposed Japanese fighters to devastating P-47 firepower. 8 50-caliber machine guns could destroy any aircraft with short bursts. Production statistics revealed American industrial dominance. Republic Aviation's Farmingdale plant covered 2.5 million square feet. Employment peaked at 24,000 workers during maximum production. The Evansville, Indiana plant added tremendous additional capacity. Together, they manufactured more P-47s than Germany produced fighters of all types. The mathematical reality was absolutely stark. American industrial capacity combined with aircraft survivability created insurmountable advantages. German planners could not match this overwhelming material superiority. Their aircraft industry lacked both resources and manufacturing capability. Cost analysis proved equally revealing about American priorities. A P-47D cost approximately $85,000 in 1944 currency. Training a replacement pilot represented $75,000 in investment. The combination totaled $160,000 per combat team. If P-47 survivability saved even one pilot from death or capture, the entire investment was completely justified economically. Over the war's course, Thunderbolt survivability saved hundreds of pilots. They would have died in less robust aircraft designs. The return on investment exceeded all expectations. The 56th Fighter Group ended the war as Europe's highest-scoring American unit, 677.5 aerial victories. Every single kill achieved with P-47s, despite pressure to convert to P-51 Mustangs. Colonel David Schilling commanded the group throughout most campaigns. His statement summarized pilot attitudes perfectly. "We stayed with the Thunderbolt because our pilots trusted it absolutely. They knew no matter how badly damaged, the P-47 would probably get them home." Individual survival stories accumulated into legendary status. Lieutenant Quincy Brown's experience on February 8, 1944, typified P-47 toughness. His aircraft collided with a Focke-Wulf 190 during aerial combat. 3 feet of right wing tore away completely. Jagged metal edges marked the separation point. The engine cowling crumpled from impact forces. Propeller blades bent at impossible angles. Brown flew 200 miles to his home base. The aircraft handled poorly with asymmetric wing loading. Control inputs required constant correction. Landing approach demanded precise speed control. He touched down successfully despite severe structural damage. Maintenance crews repaired the aircraft within days. It returned to combat service immediately. The German pilot died in the collision. Captain Johnson McGinn survived direct hits from heavy flak. March 24, 1945, brought his closest call. An 88mm shell passed completely through his right-wing structure. Miraculously, the shell failed to detonate properly. It left a hole large enough for a man to crawl through. Wing spars remained connected by thin metal strips. The entire structure flexed visibly with each control movement. McGinn flew home, watching his wing bend and twist. Each air current caused alarming structural movement. Landing required delicate touch on the controls. Too much force might cause catastrophic failure. Republic engineers studied the damage extensively afterward. They calculated that any other fighter would have suffered immediate structural collapse. The P-47's massive construction absorbed stresses that would destroy lighter aircraft. These technological lessons influenced post-war aircraft design philosophy. The A-10 Thunderbolt Reevaluated, developed during the 1970s, drew direct inspiration from P-47 survivability concepts. Redundant hydraulic systems protected against battle damage. Armor plating shielded critical components from ground fire. Engines mounted high avoided small arms damage. The design philosophy traced directly to lessons learned from P-47 combat experience decades earlier. Veteran accounts consistently emphasized absolute trust in their aircraft. Lieutenant Colonel Robert Basler flew P-47s throughout the European campaign. His words captured pilot sentiment perfectly. Flying the P-47, I never worried about the airplane failing me. Engine problems, battle damage, system failures. The Thunderbolt handled them all. That confidence let me focus on fighting rather than worrying about survival. German veterans provided contrasting perspectives from the other side. Luftwaffe ace Heinz Baer scored 220 victories. His assessment of P-47s revealed grudging respect. The P-47 was our most frustrating opponent. We would score hits that should destroy any aircraft. Watch pieces fly off, see smoke and flames. Yet the Thunderbolt continued flying and often shot back accurately. German understanding of combat damage was completely inadequate. Their experience with fragile aircraft created false expectations. P-47s defied every assumption about battle damage effects. Maintenance perspectives proved equally important to combat success. Crew Chief Sergeant Anthony Garzino serviced P-47s throughout European operations. His experience was typical of ground crews. We'd see Thunderbolts return with damage that seemed completely impossible. Cylinders shot off, oil lines severed, control cables hanging by single threads. We'd work all night, and the plane would fly again next day. The P-47 was designed specifically for field repairs. Components were accessible and replaceable. Standard tools could perform most maintenance tasks. Spare parts were interchangeable between aircraft. Statistical analysis confirmed anecdotal evidence completely. The 56th Fighter Group's maintenance records showed remarkable repair rates. 73% of damaged aircraft returned to service within 72 hours. Major structural repairs were completed within 2 weeks, maximum. Only complete destruction or loss over enemy territory permanently eliminated aircraft from squadron inventory. This repair rate was unprecedented in combat aviation history. Supply chains supporting P-47 operations demonstrated industrial warfare at peak efficiency. Pratt & Whitney produced 125,000 R-2800 engines during the war. Each engine contained 2,800 individual precision parts. The global supply system delivered engines, spare parts, ammunition, and fuel across vast distances. A damaged P-47 in England could receive replacement parts manufactured in Connecticut within 10 days. Ammunition consumption revealed the true scale of P-47 operations worldwide. Each Thunderbolt carried 3,400 rounds of 50 caliber ammunition when fully loaded. The 56th Fighter Group alone expended over 10 million rounds. Each individual round required manufacturing, shipping, quality control, and loading. The logistical achievement matched the combat success completely. American industry supported global operations efficiently. The human dimension transcended cold statistical analysis entirely. Behind every survival story was a pilot who lived because his aircraft absorbed punishment that would have killed him in any other fighter. Multiplied across thousands of combat missions, P-47 survivability represented thousands of families. Fathers, sons, and husbands welcomed home after the war. Lives preserved by superior engineering and construction. Lieutenant Colonel Francis Gabreski, the top-scoring P-47 ace, summarized the aircraft's combat impact. His words carried the authority of personal experience. The P-47 gave us confidence to engage superior numbers, attack heavily defended targets, and push our attacks home regardless of damage. We knew the Thunderbolt would take care of us if we took care of it. This mutual trust between man and machine won the air war. Pilots pushed beyond normal limits because they trusted their aircraft. Aircraft performed beyond design specifications because pilots demanded it. Final statistics were absolutely compelling evidence. 15,683 P-47s manufactured during the war. 3,499 lost to all causes in combat operations. 746,000 combat sorties flown worldwide. 4.6 to 1 aerial kill ratio achieved. 0.7% loss rate per sortie. The numbers spoke for themselves. Behind these statistics lay fundamental truth about aerial warfare. The P-47 Thunderbolt's unprecedented survivability changed the mathematics of combat completely. Traditional performance advantages became secondary considerations. By war's end, German pilots developed grudging respect, bordering on genuine fear. Luftwaffe training documents from early 1945 stated official policy clearly. Avoid engagement with P-47 formations unless possessing overwhelming numerical superiority and tactical advantage. Emergency procedures emphasized specific attack methods. If engaged, attempt to damage oil cooling system or turbo supercharger intake. Do not expect single hits to destroy the aircraft completely. German recognition was brutally honest. The American Thunderbolt has proven capable of sustaining damage that would destroy any German fighter design. Pilots must adjust expectations accordingly. The legacy extended far beyond simple combat statistics. P-47 proved that aircraft design philosophy could prioritize survivability without sacrificing combat effectiveness. Previous fighter designs emphasized performance above everything else. The Thunderbolt demonstrated that keeping pilots alive was equally important as shooting down enemies. This revolutionary philosophy would influence military aviation for decades afterward. Test pilot reports from Republic Aviation revealed engineering decisions behind P-47 survivability. Every component was overbuilt by contemporary standards. Wing spars designed for 12G loads when 9G was considered adequate. Control cables doubled in thickness compared to standard practice. Fuel lines routed through protected channels away from vulnerable areas. Engine mounts reinforced to survive crash landings intact. The weight penalty was accepted as the price of survival. Engineers understood that pilot lives were worth extra pounds. This philosophy contradicted prevailing lightweight design trends. The Thunderbolt's size, initially seen as disadvantage, proved to be tremendous asset. Large fuselage provided space for armor protection, redundant systems, and structural reinforcement throughout. The massive engine served as frontal armor protection. Wide-track landing gear enabled safe landings with tire damage. Every apparent weakness contained hidden strength that combat would reveal. Combat tactics evolved to exploit P-47 advantages systematically. Dive attacks from altitude using exceptional diving speed over 500 miles per hour. Zoom climbs after attacks, converting speed back to altitude advantage. Head-on passes, where the R-2800 engine provided maximum protection. These tactics required aircraft capable of sustaining damage during aggressive maneuvering. The P-47 met these demands perfectly. Industrial stories paralleled combat narratives completely. Republic Aviation transformed from small company producing 30 aircraft monthly in 1941 to industrial giant producing 500 monthly by 1944. The workforce expanded from 3,000 to 24,000 employees. Manufacturing techniques evolved to support mass production while maintaining quality standards that pilots' lives depended upon absolutely. Quality control at Republic Aviation became legendary throughout the industry. Every engine was test run for 8 hours before installation in aircraft. Every aircraft was test flown before delivery to combat units. Manufacturing defects that might cause combat failures were ruthlessly eliminated. Workers understood that their craftsmanship directly affected pilot survival chances. Signs throughout factories reminded employees constantly, "A pilot's life depends on your work." This message appeared everywhere workers could see it. Production quality reflected this life-or-death responsibility. Learning curves were steep but ultimately successful. Early P-47Bs suffered from engine problems, radio failures, and canopy malfunctions. Each problem was systematically identified and permanently corrected. By the P-47D model, reliability had improved dramatically. The P-47D-25 and later versions incorporated lessons learned from thousands of combat missions worldwide. Survival features were continuously refined based on battle damage analysis. Every aircraft loss was investigated thoroughly. Improvements were implemented in production immediately. Pilot training evolved to exploit P-47 capabilities fully. The aircraft's weight and power required different flying techniques than lighter fighters. Energy management became absolutely critical. Maintaining speed in combat was essential. Using vertical maneuvers rather than horizontal turning battles. Trusting the aircraft to absorb damage while pressing attacks home. These lessons were learned in blood. Training programs at bases from Bradley Field, Connecticut to Millville, New Jersey, produced pilots capable of maximizing P-47 advantages. Graduates understood their aircraft's strengths and limitations completely. The contrast with German aircraft was absolutely stark. Messerschmitt Bf-109s with liquid-cooled engines failed with single coolant system hits. Focke-Wulf FW-190s with BMW 801 radials were more robust, but still vulnerable. Neither possessed armor protection, redundant systems, or structural strength of P-47s. German pilots fought, knowing that serious damage meant death or capture. No margin for error existed. Intelligence assessments confirmed psychological impact on German morale. Intercepted communications revealed growing pilot reluctance to engage P-47 formations. Luftwaffe morale declined steadily as pilots witnessed apparently destroyed Thunderbolts continue fighting. The term Thunderbolt fever appeared in German medical reports. It described anxiety disorders among pilots assigned to intercept P-47s. Fear replaced confidence in German pilot ranks. Pacific theater operations provided different validation of design philosophy. Operating over vast ocean distances, engine reliability meant survival or death. The R-2800's ability to run despite damage proved crucial. When nearest friendly base was 500 miles away, engine failure meant certain death. Navy pilots flying Grumman F-6F Hellcats and Vought F-4U Corsairs, also powered by R-2800 engines, reported similar survivability advantages. Maintenance crews developed remarkable expertise repairing seemingly impossible damage. Cylinder replacements in forward airfields using basic tools. Control surface reconstruction using salvaged materials from wrecked aircraft. Engine overhauls under combat conditions with improvised facilities. The P-47's design facilitated field repairs that would have required factory facilities for other aircraft types. The spare parts system was absolutely revolutionary for its time. Republic Aviation established part numbering systems that became industry standards. Every component was cataloged, tracked, and distributed based on actual usage patterns. High-wear items were pre-positioned at forward bases worldwide. The result was unprecedented aircraft availability rates exceeding 80%, despite continuous combat operations and battle damage. Combat photography documented the reality of P-47 survivability dramatically. Gun camera footage showed Thunderbolts absorbing streams of cannon fire while maintaining controlled flight. Post-mission photography revealed aircraft that seemed impossible to fly. Wings with gaping holes larger than automobile doors. Fuselages resembling colanders from multiple hits. Engines with cylinders blown completely away, yet still running. These aircraft had returned to base under their own power. Cost-benefit analysis was overwhelmingly positive for the program. A P-47 that survived severe damage saved not only the pilot, but the investment in training and irreplaceable experience. Veteran pilots were absolutely irreplaceable assets in combat. Their survival meant continued combat effectiveness for entire squadrons. The Luftwaffe's loss of experienced pilots created downward spirals of declining capability. Weather operations demonstrated another critical survivability advantage. P-47's robust construction enabled operations in conditions that grounded other aircraft completely. Ice accumulation that would destroy lighter aircraft was manageable. Turbulence that would cause structural failure was absorbed safely. Rain and mud that made operations impossible for German aircraft were routine for Thunderbolts operating from forward airfields. Night operations, though limited, proved feasible with modifications. P-47s equipped with exhaust flame dampeners and basic night-flying instruments conducted intruder missions over German airfields successfully. The aircraft's stability and predictable handling characteristics made instrument flight possible. Several pilots survived night combat damage that would have been fatal in aircraft requiring more precise control inputs. The culmination came during Rhine crossings of March 1945. P-47s flew continuous ground support missions facing desperate German resistance. Concentrated flak batteries fired from prepared positions. Emergency Luftwaffe fighter sorties attempted to disrupt Allied air support. Man-portable anti-aircraft weapons appeared in increasing numbers. The Thunderbolts absorbed unprecedented damage while maintaining operational tempo. Not a single Allied ground unit reported failure of air support due to P-47 losses. The aircraft continued flying missions despite damage that would have grounded entire squadrons of other fighters. Colonel Zemke, reflecting on his command of the 56th Fighter Group, stated the fundamental truth. The P-47 changed the equation of air combat. Previously, aircraft with superior performance held advantages. His assessment continued with hard-won wisdom. The Thunderbolt proved that survivability could overcome performance disadvantages. Our pilots learned they could accept battle damage that would destroy enemies and continue fighting effectively. That psychological edge proved absolutely decisive in aerial combat. German pilots lost confidence while American pilots gained it. The mental aspect of warfare favored Thunderbolt pilots completely. The numbers told the complete story by May 8, 1945. P-47s had flown more combat sorties than any other American fighter worldwide. They had dropped more bombs and fired more rockets than competitors. They destroyed more ground targets than any other Allied aircraft. Most importantly, they brought more pilots home alive, despite sustaining battle damage that defied conventional understanding of aircraft survivability. German ace Adolf Galland's final assessment was brutally honest. The P-47 was not the best-performing Allied fighter. The Spitfire turned better. The P-51 had longer range. The P-38 had better visibility. His conclusion carried the weight of bitter experience. But the P-47 was the fighter we feared most because it could not be stopped. Our pilots called it the unbreakable. In the end, that quality proved absolutely decisive. The last P-47 combat mission in Europe was flown on May 7, 1945. Appropriately, the aircraft returned with battle damage. 23 bullet holes from German flak peppered wings and fuselage. The pilot was completely uninjured despite the hits. The aircraft would have flown again if the war had continued. It was a fitting final demonstration of the quality that had stunned German pilots. The P-47 Thunderbolt's ability to survive everything the enemy could throw at it. That was its greatest victory and most lasting legacy in military aviation history. The legacy lived on in pilot memoirs, technical manuals, and design philosophies for decades. Every modern military aircraft incorporates lessons learned from P-47 combat experience. Redundant systems, damage tolerance, armor protection, structural overdesign. The principles that saved thousands of Allied pilots continue protecting military aviators today. The P-47's influence on aircraft design philosophy cannot be overstated. In final analysis, the P-47 Thunderbolt represented more than successful aircraft design. It embodied American industrial philosophy of overwhelming material superiority combined with innovative engineering solutions. It proved that technology could provide decisive advantages when properly applied to military problems. Most importantly, it demonstrated that prioritizing pilot survival was not just humanitarian, but strategically essential. German pilots who faced P-47s in combat never forgot the experience completely. In post-war interviews, veteran after veteran described shock at seeing Thunderbolts absorb damage that would destroy any aircraft in their experience. They continued fighting effectively, despite impossible damage. The psychological impact of facing apparently indestructible opponents contributed significantly to the Luftwaffe's ultimate defeat in aerial warfare. The statistics were absolutely staggering, but human stories were more important. Behind every number was a pilot who survived because American engineers had built an aircraft that refused to die. Families reunited after years of separation. Children who grew up with fathers present. Communities that welcomed home their heroes. The true victory of P-47 Thunderbolt was measured in American lives saved. The Thunderbolt proved that in brutal mathematics of aerial warfare, survivability could be as decisive as firepower or performance. German pilots were stunned to discover their opponents flew aircraft that violated fundamental laws of aviation physics. The P-47 absorbed punishment that should have been fatal and kept flying, kept fighting, kept bringing its pilots home safely. That was the legacy of Republic P-47 Thunderbolt. Not just victory, but survival. Not just air superiority, but preservation of trained aircrew who would continue fighting until enemies were completely defeated. In skies over Europe and Pacific, the Thunderbolt wrote its legend in armor, steel, and American determination. It was quite simply the fighter that survived everything enemies could deliver.